Hi, I'm an old guy and I do maths, and today what we're going to attempt to do is sketch the graph of y equals 2 sine 3x minus 2, and I haven't put any limitation in here on the domain, but we'll go between 0 and 2 pi because that's what I've got graphed here. Now the first thing that I want to do is to talk to you about what each of these numbers does. So the first thing is that this 2 here has an effect upon the amplitude of the graph. The normal amplitude of a sine graph, I've got one here which I've drawn earlier. The normal amplitude of a sine graph is 1. That's the distance between here and here, or here and here, because amplitude is something that has magnitude, so it's not negative because it's here. So the range of this function here is between 1 and -1. So if we increase the amplitude, if we take, I don't know, let's just say we put a 2 here. This point here would go down this way, this point here would go up this way, and the distance between here and the new point would be 2 units. So that's what this means. Let's deal with this one secondly. What that does is, if everything else here were pretty standard, so if this were 1 and this were 1, all that this would do is move the graph from a median point here down to here. And that's usually indicated by a dotted line, which I'll draw in now, just so that you can see it. So this dotted line will be the new median value of the sine function that we are dealing with. And the median value is simply the middle value of all the values of a sine function. So in this case the median value is 0. Okay, now the last thing that I've got here is this 3. And the 3 affects the period of this graph. Now the formula for a period is 2 pi on n, and the 3 is n. So in this case, instead of the period of the graph being 2 pi, and again to refer to this drawing, the period is the distance from this point to this point, as in the movement of this graph all the way through one cycle and its return to where it started. That is the period. In this case it's 2 pi. The standard period for a sine graph is 2 pi. But in this case we have 2 pi on 3, which means that the distance of the period is going to be divided by 3. It's going to be compressed. So let's just consider the implications of that. So this thing is going to go through a cycle in the space of 2 pi on 3, which means that we're going to see a few ups and downs here. Now, a normal sine graph, this one here for instance, this reaches its maximum value at pi on 2. Now, the maximum value that this function is going to reach is at pi on 6, which is pi on 2 divided by 3. So we're going to have a point here. Let's see. Pi on 6, so this is 180 degrees, pi. We're going to divide that by 6. So pi on 6 is over here somewhere. And our period is 2 pi on 3. So if we add pi on 6 to 2 pi on 3, that has the effect of adding pi on 6 to 4 pi on 6. I'll just do this, I'll just move this page slightly and I'll do the calculation for you. So pi on 6 plus 2 pi on 3, which is the period. So what we're doing is we're going to calculate the distance between here and the next point at which it strikes this, this x-axis. So 2 pi on 3 is the equivalent of 4 pi on 6. So that's pi on 6 plus 4 pi on 6, which is 5 pi on 6. Now 5 pi on 6 is about there. So we'll say 5 pi on 6. So what I'm doing is I'm working my way across the maximum points of this function to see where it strikes the x-axis. And if we take 5 pi on 6 and we add the equivalent of 2 pi on 3, which is 4 pi on 6, we get 9 pi on 6, which is, we can simplify that, that is 3 pi on 2. So we're going to get a point 3 pi on 2, which is roughly there, 3 pi on 2. So what I've done is I've divided 9 pi on 6, I've just divided through by 3 to simplify this, and we've got 3 pi on 2. Now, I can get drawing. Now, what I'm going to do is just sketch in the point from where this graph starts. This would normally be 0, but we've moved this down 2. Up to here, pi on 6. I need to find a midpoint between these two values here. At the moment, I can just estimate that on the graph, but I will actually work that out. And so this graph goes down like this and passes through this point, and will come up to here and pass through this point. So the midpoint between these 2 points is actually 3 pi on 6, which is pi on 2. Okay, so this point down here is pi on 2, simply the midpoint because these things are symmetrical. And the midpoint between 5 pi on 6 and 3 pi on 2, it's easier if you work this out using pi on 6, but it's going to be 7 pi on 6, which is approximately here. 7 pi on 6. And so I can draw this graph down to here, and this value here is 7 pi on 6, and then back up here to 3 pi on 2. Now this is very elongated I guess simply to give me enough room to draw this thing, because I'm not great at sketching all of this. Now what I need to do is I need to take this value and I need to add 2 pi on 3 to it. So this was 9 pi on 6, and I'm going to add the equivalent of 3 pi on 2 to it, which is 4 pi on 6. 9 and 4 is 13 pi on 6. Now, that's actually out here somewhere. And I stated that we would leave our domain at 2 pi. So what I will do is I'll find the midpoint here between this and this, which is probably actually a little bit to the right of that. And I'll draw this in, and we'll see where we finish up. So I'm not entirely sure as to where we'll finish up, but I'll just put a point there for the moment. Now, this point here is halfway between here and our next point of contact with this x-axis, and this is a little out of whack, so I'm just going to move. This is what happens when I get drawing. We'll say that that's 2 pi. I'll check on that. I'll check on that in a moment. What I want to do is I want to get the value of this point here, and the value of this point here is halfway between 9 pi and 13 pi on 6. So it is, I'll just put it in up here, that is 11 pi on 6. So that is 330 degrees. So it's very close to 2 pi. And the distance between here and here is approximately, well, it's exactly 60 degrees, this value between here and here. So this point here is where we will finish at 2 pi. So at 2 pi, the value of this function is -2, and it is -2 because we're halfway through this cycle up here. This is the equivalent of pi on 6, and this is the equivalent of pi on 6. Half of the cycle of this, say from here to here, is pi on 3. So we can divide that cycle up again into two equal parts, despite my poor drawing. Pi on 6 with 2 pi in the middle, which is why this is halfway through its cycle and it's come back to 0. So that is the graph of 2 sine 3x minus 2 between 0 and 2 pi. And I hope that my working through this has proved useful for you, and that you can see how I've just found all of these points of, shall we say, interest by simply calculating them using the value of the period of this graph, because it's so easy, if laborious, to do this. And the other thing I would say is that you do this one thing at a time. You sort out, if you get something like this, you sort out what the amplitude is going to be, you sort out what the median is going to be, and then you can go to work on what the thing actually looks like, dealing with things like period. Okay, well, thank you very much for watching. I hope this was useful, and I'll see you next time. Please don't forget to subscribe and like.